Okay, section 9.2, differentiating exponentials and logarithms. So sections 9.2. Example 4 deals with the result that you need to remember. We're going to derive it. We're going to show that the derivative of a to the power of x is a to the power of x ln a. And I'll do it in two different ways. Okay, the way one is to start off by y equals a to the power of x. You may say let y equal to a to the power of x, and then you need to rewrite it. So you've got to write it as in terms of exponentials. So remember, e and ln cancels itself. So if I want to write it as e, you can write it to the power of ln a to the power of x. Okay, so that's how you could rewrite it. And then you are going to use the power rule to do with logarithms, so x can be brought down, and this can be written as y equals e to the power of x ln a. Now remember, ln a is just a constant, so ln a is just a constant, so ln a is a constant. So this here is simply differentiating something like y to the power of y equals e to the power of k x if you were to put ln a in front of x, and that differentiates to k e to the power of kx. So if your k was equal to ln a, what will happen here, dy dx is going to be equal to k, which is ln a in our case, e to the power of kx. So e to the power, we were going to write it as they've done it, k x ln a. There you go. Now all you need to do now is just rewrite it. So ln a, then e to the power, let's move that x back as a power, and e and ln cancel, and you are left with ln a multiplied by a to the power of x. But we tend to write it in front because we don't want to be writing a the times symbol. So a to the power of x ln a is our result. There you go. I'm going to show you way two. I'm going to a little bit earlier, I guess. It's weird too, but never mind. Introduce you to a result that you are going to learn about in next section. Okay, and that result is that dy dx is equal to 1 over dx dy, and the opposite. So if you want to have dx dy, all you need to do is flip dx dy dx. So they're reciprocals of each other. So how do we do it? So we're going to also allow let y equal to a to the power of x. And then what we're going to do, we're going to introduce natural logarithms. So we're going to put ln y must be equal to ln a to the power of x. And then ln y, x can be brought in front of ln a. And then x is equal to, we're going to divide by ln a. So I'm going to write it as 1 over ln a times ln y, because then 1 ln a is also a constant. Okay, now we're going to differentiate x with respect to y. So we're going to put dx dy, and that is going to be equal to constant of the differential of ln y. And the differential of ln y, which we are going to start using it in this section. So ln y differentiates to 1 over y, because if you have ln x, that goes to 1 over x. So the idea is that we are going to keep that as a constant times 1 over y. But y is a to the power of x, so you've got dx dy is equal to 1 over ln a times a to the power of x. And all we need to do is now use this result. Let's flip those sides, and you're going to get dy dx is equal to a to the power of x ln a. So our result has been proven. Okay, the results from section 9.2. So far we actually know that e to the power of kx from last year differentiates to k e to the power of kx. So effectively it stays the same, but then gets multiplied by k, the coefficient of x. Ln x differentiates to 1 over x, so this is the result I mentioned in the previous example. Now actually there I want to introduce you to the next result, ln kx, and we are going to use it in this section in the next example. It actually differentiates to 1 over x, okay, and that will become obvious when I show you how to do it. And we've proven this result. This goes to itself, but it's multiplied by ln a, so we tend to put a to the power of kx and then times by ln a. So these are the results that you should put on your flashcards, or if you keep them together, something you need to memorize. Okay, so we're going to use these in our example 5. So if y is equal to e to the power of 3x plus 2 to the power of 3x, what I have over here is the result from last year to begin with. There you go. And that's going to be 3e to the power of 3x. Now, in order to differentiate this second result using our last method over here, you can do it in two different ways. One way is the idea of rewriting it first. Okay, so let me rewrite it, and I'll show you a different way as well. So this can be written as 2. Remember, the power gets multiplied when you raise something to two different powers, so twice. So you could rewrite it as 8, or I'll write it as 8 to the power of x. And then you've already differentiated the first term, then this one here is going to go to plus, and over here it's going to go to itself, followed by ln 8. Okay, now you may want to rewrite it in terms of 2 to the power of 3 if you want to. So that will be 2 to the power of 3 to the power of x, and then you've got ln 2 to the power of 3. And this will become, let me just squeeze it in here, 2 to the power of 3x. But then it's that 3 can be brought in front, but we might as well bring it in front of the whole thing. So 3 times, I need to put the times symbol, ln 2. So it looks a bit, I think it looks better when you write it with 8, but you know, it's fine to write it like this. Okay, now a different way of doing it, let me just do it over here. Okay, I'm just going to focus on the second part. Okay, so if you have to differentiate 2 to the power of 3x. So what you need to do then is you're going to apply what's called the chain rule, which you are doing over here. So notice if you had kx in the power instead of x, you had to multiply by k. So here we have got 3x in the power, so we'll follow the rule of the last rule that I've listed, but we'll have to multiply everything by 3. So the first thing that it happens that it goes to itself, so 2 to the power of 3x. Then it's followed by ln of 2. And then you need to multiply everything by 3. There you go. So you can put the 3 in front and you get 3 times 2 to the power of 3x ln 2. And that was our second part in this differential. Okay, y equals ln x to the power of 3 plus ln 7x. So in order to do this, we need to prepare it a little bit. Later on, we'll learn a little bit more on chain rule, and you'll be able to apply it a bit quicker. But here, in order to use our rule, we've got to rewrite it. So bring the 3 in front of ln, so we've got 3 ln x. And this here, we need to split it into a sum. Remember, log of the two terms multiplied by each other is equal to log of the sum of logs. Now we are able to differentiate it. So let's differentiate each term as we go along. So remember, ln x goes to 1 over x. So this will go to 3 times 1 over x. ln 7, this is just a constant. Constant, remember, if I put 2 here, it will go to 0. Any constant will go to 0. And then you've got another 1 over x. Okay, so you've got 3 and 1 lots of 1 over x, so overall 4 over x, because 4 lots of 1 over x is 4 over x. And that's it. Okay, and finally in this result, it has to be prepared for differentiation. You know, you can't differentiate the top and divide it by the differential of the bottom. You're not allowed to do that. The same way you couldn't do it with the power functions last year. You had to do the dividing. So we have to do the same here. So if we divide 2 by 4 to e to the power of 3x, and then minus 3e to the power of 7x over 4 e to the power of 3x, we can still rewrite it. Let me just keep it in one line here. So this will become 1/2, and we can bring that e to the top and give it a negative power. And then you've got 3 over 4, the coefficients, and then e, remember you need to subtract the powers to the power of 4x. There you go. So it's brilliantly prepared for differentiation. Let's put dy dx equals, let's bring the minus 3, because that's k e to the power of kx. So it's minus 3 times 1/2 is minus 3 over 2, e to the power of minus 3x, minus, and here we're going to times it by 4. So 4 times 3 over 4.
Here's what I found.
E to the power of 4x. There you go. Let's just tidy up this coefficient. So you've got minus 3 over 2, e to the power of minus 3x, minus 3 e to the power of 4x. So this is the end of example 5.